name is Zoltan Arato. I'm a product manager of Google Cloud IoT Core. Let me also introduce Preston Holmes, head of IoT solutions for Google also. He's going to be on stage with us shortly. So today we are going to talk about a specific type of IoT applications. Applications, those involve, of course, IoT devices, mobile or web applications, and very importantly, also users. And you are going to see that users will be an important component in this presentation. And as part of this presentation, we will review sort of the theoretical background, the business context, and then we will show you a toolbox using Cloud IoT Core and some of the Firebase products, how you could implement these use cases. And we will finish with a demo. So both Preston and I have been working in around IoT projects or on IoT projects for almost 5 years now. And we have seen two main patterns emerging when it comes to IoT use cases. The first one is, I like to call them data ingestion intensive or data ingestion heavy use cases. In these use cases, there are many devices sending a lot of data upstream. So typically, the bandwidth requirement upstream is much higher than downstream. And usually, these are applications for monitoring or analytics. And I mentioned that users will be an important part of our talk. And in these use cases, usually there are less personas involved. On the other hand, the other type of application we usually see when working with customers, we like to call it complex application logic use cases. So in these use cases or applications, the data model is usually more complex. There is a similar need in terms of bandwidth requirement upstream and downstream. And that's because these applications are not only about receiving data from devices, but also controlling them. So most of the time, this complex business logic is used to determine some sort of change that is required to be performed on the devices and then send back these commands or configurations to the devices. And what makes implementation of these use cases challenging is the multiple personas sort of in the mix or having to interact with these deployments. So when it comes to these complex application logic use cases, typically these are the building blocks that we see as required for implementation. So mobile and web applications to control the devices and see their actual state. The devices, of course. Device management capabilities, meaning like credential management, grouping, upgrading or updating the firmware of the devices. Cloud services, data management tools in the cloud, or storage solutions or computing solutions. User management, so most commonly an identity provider to store your users and then handle your users. We already touched upon command and control, so the capability to interact with the devices, to be able to control them. And last but not least, sensor data aggregation and visualization. So you want to see, or in these use cases, users want to see sensor data or aggregated data of one device for multiple devices. And there is a horizontal layer here. So all these building blocks are used by various users and personas. And these users may have very different access control needs or limitations. And this is going to be a focus in our talk, how to implement authorization for these users, because we have seen that many times this is very challenging. So depending on how the business is run, the same building blocks are used. And there are three main categories here. We are going to see examples for each. So B2B, business to business, B2B2B, there is another B added here, and B2B to C. And the first B is always the IoT or cloud service provider. So in our case, it's Google Cloud, and then the second B is our customer, and in many times, our customers operate a service, some sort of SaaS service, an IoT solution using our infrastructure, and sell these services either to businesses or consumers. So to give you an example of all of these, probably the B2B scenario is the simplest in terms of implementation. And probably the best example would be a connected factory or connected manufacturing line, so a factory with connected PLCs. When it comes to implementing these use cases based on these business models, usually it's enough to use the resources provided by the cloud service provider, so in this case, Google Cloud. So these are existing resources or building blocks, and implementing these use cases can rely only on these components. And very importantly, there are no end users in B2B use cases. This is a little bit more complicated, the B2B2B scenario. Maybe the best way to describe this category of use cases is through an example. So imagine a connected truck fleet management system, a company that provides this truck fleet management service as a SaaS service, and they also, let's say they also sell hardware that their customers can install in their trucks, or it can be other vehicle as well. And there are end users in this scenario. So if you think about the customers of this SaaS provider, so the connected truck fleet management system provider, those users are end users. So for instance, a driver or operator of a given fleet. And we have to realize that in these use cases, there is a really wide spectrum of roles and permissions. So just to reflect on my previous example, a driver has really different access rights compared to the manager of a whole fleet. The B2B2C scenario is a little bit simpler, but similar to the previous one. Probably this is the most familiar to all of you. A good example would be a smart lighting solution. Really the only difference here is that the end users are consumers. And in these use cases, there are multiple personas and roles and permission requirements, but typically less than in case of B2B2B. I wanted to show you a real-world example, and it's very relevant here in San Francisco. So you might have seen these scooters out on the streets. These are connected scooters, so they are connected to the internet. And there is a corresponding app, or there is an app you need to use if you want to ride the scooter. And there is a very complex business logic behind this service. So if you think about it, the user of the application and the scooter needs to gain access rights to the scooter just for the period of that person is riding this scooter. So this is a pretty complex business logic here, and they are actually using Google Cloud services. Just to give you a summary of these various business models or sort of overview them. So in all cases, the manufacturer is some kind of device maker or an OEM. That's common in all three scenarios. When it comes to the owner of the devices, so who owns the device? In case of B2B, this is trivial. It's the customer of the cloud service provider, so it's a corporate owner or an operator. And there is no end user in case of B2B. In the other two categories, there are end users. In case of B2B2B, the interesting thing is that the owner is also a corporate owner or operator, but the end user is different, so they don't necessarily own the hardware. So just to reflect back on the truck fleet management system, this hardware or these tracking devices might be installed on trucks, but let's say the driver of the truck doesn't necessarily own the device. In case of B2B2C, this is a little bit simpler because in these use cases, usually the owner and the end user are the same person. So think about the connected light example. All right, so when it comes to the implementation, and we will go into the actual details very soon, but just to review that there are two main layers of the sort of back-end implementation of these use cases, application and infrastructure, just like in other systems. This is true in IoT as well. So what's typical for infrastructure is that usually there are cloud services, and these are pre-existing building blocks. So for instance, like compute engine instances or devices, but there are many of them in Google Cloud. What's common is that there is a service called Cloud IAM, and Cloud IAM controls that what sort of permissions a given user has on what resources. And in this layer, the resources are obviously defined by the cloud service provider. So in our case, it's defined by Google. And typically, in case of B2B use cases, the implementation is heavier on this layer. So there is less need for an application layer because you can usually use these pre-existing building blocks. The application layer, this is where the business logic, most of the business logic is implemented. This is where the command and control decisions are made. And this is the layer responsible for transmitting these decisions to the infrastructure layer. We can look at this layer as the digital version of the business model of a given use case. And this layer is usually thicker in case of the B2B2B and B2B2C use cases. Now, an interesting question is that, of course, these two layers live together. So they are implemented together and both exist. And there is always some sort of overlap between the two. And the question is, how do we cross over between the two layers? How do we bridge between a device that only exists as an infrastructure piece and its authorization is controlled by IAM? So how do we provide access to this device for a user that, for instance, only exists in a third-party identity provider, which can be even external to Google? And the good news is that Google has solutions to solve these problems, and we have tools to implement these authorization control mechanisms. And so I would like to invite Preston on stage to tell more how to do that.
Thank you, Zoltan. So we talked about the general cases of the infrastructure layer and the application layer. So if we look first at some of the infrastructure ways that we can apply IAM in IoT, Cloud IoT Core, which is our primary service for authorizing and identifying and securely connecting devices that exist out in sort of the field to cloud, this service has a set of IAM permissions and roles that let you define who can do what with the logical device resources that are stored in IoT Core. And like many cloud IAM permissions, these can be applied at different scopes of influence. So this is an example of where these permissions can be applied to the entire project. But inside Cloud IoT Core, we also provide the ability to apply these permissions or roles to specific device registries or collections within a project. So this is something where you're applying Cloud IAM to control who can access or who can perform certain actions on cloud resources defined by Google in a managed service like Cloud IoT Core. The other thing you can use IAM for is controlling access to who can publish to certain Cloud PubSub topics. So Cloud IoT Core and Cloud PubSub are very tightly integrated. And by limiting who can publish to certain topics, you can constrain PubSub that they're only messages being published by devices through IoT Core arrive on a PubSub topic. And this is important because that way you can use certain attributes published by IoT Core on messages such as a device ID and know that those attributes were only coming through devices and not through some other cloud publisher online that has access to that PubSub topic. So it's one of the constraints you can put on other systems that IoT Core interacts with. Now, the title of this talk was IoT and Firebase is actually a very large suite of products and services. And we're certainly not going to cover them all today. There's also the fact that a number of these services now sort of have dual representations in both sort of the Firebase experience and the cloud GCP experience. So the ones we're going to be touching on are authentication, hosting, Firestore, and cloud functions. So authentication is the kind of customer identity management. I'll get into that in a sec. Hosting is static hosting. Firestore is a document database. And then cloud functions, again, this is the same backend infrastructure shared between Google Cloud Platform and Firebase as far as executing lightweight functions. So the first is around identity management. So when Zoltan was talking about the main components, this is how you manage your own users. So when you do have end users involved, you need a way of managing who they are. This handles user authentication. Recognizing that these users exist in your system. So when a developer logs into Google Cloud Platform, our Google identity system is what we expect infrastructure users to be able to log into. Now you can integrate that with AD, et cetera, but that's identity management for infrastructure. This is identity management that we offer as a service for you to incorporate into your own applications. And once you have authentication, then to address authorization, this is where Firebase rules that apply to Firestore come in. And this is a service that allows applications to communicate directly to the database without needing to go through any sort of API middle tier. And if you're going to have applications talking directly to a database, you need to apply authorization logic. And the way we do that is we have a service that basically lets you describe that authorization syntax in your application and have the database actually apply that for you. So we'll get a little bit more into some of the syntax for these rules a little later. But let's talk about the kind of architecture we're going to show and demonstrate here, and that is we've got some devices on the left. These are kind of hypothetical sort of gas sensors in this case we're going to use, and then end users interacting with an application on the right. So the first thing we do is we're going to use Cloud IoT Core to securely connect the devices to the cloud. And then on the application side, we're going to host the static content related to the application and deliver that to users in web browsers or mobile applications from Firebase hosting. And then the live data that the application is going to be interacting with is going to come from Firestore. But because Firestore is directly connected to the application, we're going to make sure that Firestore rules are applied to the way the application is getting data in and out of Firestore. Now, to connect these two for device sensor data, we're going to use the Cloud IoT Core's integration with PubSub and then Cloud Functions that take readings from sensors and write them into Firestore. We also could have chosen other cloud platform database products to do this. For example, we could write this sensor series data into Cloud Bigtable. Very scalable way of doing series data, to be honest. And in this case, it would have also meant we would have had to replace the Firestore rules with our own authorization implementation. So we're going to go with the simple path here and just use Firestore because it gives us that rules sort of value. We're also going to send information from the device into Firestore about the current settings and state of the device. So this isn't necessarily the sensor data, but this might be other current settings and values that are on the device changing less often. And then finally, when a user changes a setting in a device, we need to get that back out to the device. So again, we use a Cloud Firestore trigger to run a cloud function when data changes in Firestore, and that cloud function then can send the updated configuration through IoT Core to the device. So when you put it all together, it looks a little something like this. So what we're really trying to leverage here is using as many serverless and managed services. We've got direction, data flowing in both directions, and then we've got static content and data being served to an end user application. So the scenario for this demo is going to be sort of a hypothetical technician who needs to check out a piece of equipment. And here is my gas sensor that we're going to use. And what they're going to end up doing is connect to it through a mobile app. So this is, I'm going to test the demo gods because I've got an IoT device, a tablet, and a demo laptop, all concurrently interacting with our Wi-Fi saturated world. So let me log into this. So if we can have the demo system up. Got it. All right, so let's start with the, if we can go ahead and I'm going to restart the casting here. So if we can have the look that has the, I'm going to reconnect. The AV guys loved our requirements list for this one. All right, so here's the tablet. I'm going to launch this app. So the first thing is, let me go ahead and back out. I'm going to log out. So this app really doesn't do anything until you log in. So when I log in with Google, that's actually, maybe I'll just keep it that way, honestly. When I log in with Google, I've already authorized this app, so it directly is going to go to a list of devices that are associated with me. This is a new device, so I've just kind of checked this out of a rack, say a shared rack at the technician. And what's displayed on here is a code that says, let me, as an employee, claim this device so that I have sort of exclusive control over it. So if I add this claim ID, and it's my favorite one, so I'm just going to name it Fave. Most of you won't be able to see this change, but I'll hit claim. And as long as the network is still good and connected here, this now says claimed. So the device is now recognized that it's claimed. So I'm going to go into the detail view here. So what you see on that real-time live graph is light data, light sensor data coming from this device. And that's coming through that telemetry path that I showed in the architecture. You also can see that there are a set of configuration settings, and that is a tilt threshold. And so what that means is I have angle set that if I tilt this device past a certain range, I get a beep. Now, as a user, if I want to change the tolerance of those tilt settings, I can go ahead and in this app, I'm going to narrow those down. Let me just actually narrow one side here. And when I hit update, you see the little spinner up in the dialog? That's actually letting me know that it's taken a moment for the settings to get to the device, and then the device, it's doing that again, huh? Well, what you can see here is I've narrowed the tilt setting, and now it's a lot more sensitive, right? We'll go one more time. We have enough time that I can, if you bear with me, This is a relatively older tablet that I pulled out for this particular thing. So I think between us and the stage. So before it glitches again, I'll do this one more time. I'll change a setting, and I'll update it. In fact, I'll do it again one more time. I'll narrow this other direction of tilt. Hopefully I haven't put it into a state of here. We'll see here that now if I tilt this, essentially what I'm tilting. But what I want to do is show you back on the laptop a little bit about what's going on here. So that progress spinner is actually giving the user of the tablet an indication that the settings have not yet actually been verified as received by the device. So I change a setting in the UI. I update the setting. That changes data in Cloud Firestore. That change of data in Cloud Firestore triggers a Cloud function to run and send the new settings down to the device through IoT Core. When the device receives the settings and applies them to the tilt sensor, that sends another state update message back through that other top pathway, which confirms the state as updated in Firestore. And only when do those two data values reconcile does the spinner go away. So when you saw me update a setting in the tablet and you saw a spinner for a moment, that's actually a sort of a full round trip to the device and back confirming those settings. I'm going to show you a little bit more about how these Firebase rules apply, because these rules are what are preventing one user from seeing data from a device or changing settings of a device while another user has that device claimed. And the syntax of these rules is based around matching patterns of a document in Firestore. So first of all, the outcome of a rule is to allow or not allow a given device. So essentially, it's deny by default. And unless a matching rule is found, don't allow the user to actually read or write data from the database. So you can see the operations can be read or write. There's actually also update and delete. And the main one I want to point out is the kind of middle section here. So, well, I'll go from the top, which is that the first rule is around letting a user basically update their own user's profile, right? And that makes sense. Unless the user the request coming from the user matches the profile user's ID, you can't update somebody else's profile. The second one is related to the device record itself. So in this case, we want to allow a person to create a new record. If they're going to be the first to claim a device, they can have that entered. They also can read and write the settings for a given device, because that's where the updating of settings is being written to. And then the telemetry path, this is where we're storing incoming sensors. So that real-time line graph was going to a telemetry collection. Just to back up and give a little bit more context for those who don't know as much on the Firestore front, as a document database, documents are organized into collections. So here we're talking about 3 different collections: users, devices, and telemetry. And the way Firestore rules are applied is you can apply them only to documents and collections that match certain patterns. In the case of the middle one here, what we're doing is we're taking the device ID, which is also in this case the document ID, and using that as a variable in the rule. And just to show you the way this works from at the actual database layer, I have another user logged in to the same system. And since the URL path was used for getting the data from that device, if I try to put in that device URL, you'll see that not only is it being blocked at the web front-end logic, but if you look at the developer console, the permission error is actually coming from the database, right? So if I didn't show you this developer console, it'd be very easy to sort of say, oh, well, this is authorization logic happening in the application in the front end. That is subject to bugs and errors in the way authorization is applied. So here, by seeing the developer console, I can show you that this is actually being enforced at the Firebase client library and backend integration point. If I go ahead and, we don't need to put the tablet up, but I will go ahead and release this device from this user. And if I go back, I can now claim this. And now I can see it. And now I can actually get to that URL for the detailed view. So that's how we're able to use sort of the real-time nature of Firebase, Firestore to basically apply these rules based on the data that's in the database. I think that's the other key takeaway for Firestore rules, is that they are applied per request, per document, in a way that lets your own rules and your own data models in the database be that custom application layer of authorization. So while IAM has a focus on the resources or the models that are defined by Google, if you're defining the sort of application objects in Firestore, you can apply Firestore rules in a custom way to those objects in that data.